So our short list of items that we'll cover today is starting with what's the need and why is there a need for some type of new connection in the system, a new type of connection in the system, that being a plug terminated in the field. So we'll look at new network cabling challenges that are in the enterprise. We'll take a look at the methods for device cabling that are available for connecting those devices. Then we'll dig deep into the Panduit field term plug, taking a look at what it provides and how it compares to other products on the market. And finally, we'll wrap up with an example just to show you the kind of cost savings that this product can provide to contractors and to end customers. So the first question again is, what's going on in the network to create a need for a new type of connector in the market? Well, as we all know, as we see from the pictures, there are many more ceiling and wall mounted network devices which are now being installed and integrated into the typical enterprise network. Things like access points, wireless access points, of course, cameras, sensors, displays, door controls, even PoE lighting. Now, these devices all share some commonalities in that they are RJ45 port connected, meaning they have a one or more RJ45 ports into which you insert a plug from the network to physically connect the device to the network. They're also often PoE powered, and this is where the benefit of the copper infrastructure comes in. As we all know, there's a lot of PoE activity lately. Because these devices are located where they are, many times the device mobility is not needed, and the install location may be hard to access, unlike a typical desktop environment where a patch cord would be the most common thing to use to connect an RJ45 ported device. So all these things create new infrastructure challenges, and when we look at the options from a cabling standpoint for the methods to meet these challenges, the first one we'll take a look at is the patch cord method, and this is the traditional structure cabling method, where on the left side of the image you see the rack that would be typical in a telecom room, and on the far right you see a typical PoE device such as a camera, but this could also be an access point, it could be a PoE light, it could be a door control, anything like that. So in the patch cord method, we've got, of course, the components after we exit the telecom room. We've got horizontal cable, which is solid cable used for the permanent link. We would have a modular jack. We would have some type of housing for the jack. And finally, we would have a patch cord. And one end of that patch cord would plug into the modular jack. That's the end of the permanent link. And then the other end would plug into the PoE device. So this is the traditional method, and well understood, I'm sure, by everybody on the call. Now, another method, which has been introduced just recently, and there's we'll talk about in a moment the standards activity on this. This is called the direct connect method. So with the direct connect method, you can see that we still have the telecom room represented there on the left, and the PoE device represented on the far right. And in this method, the components that we have in the link to connect the device are simply the horizontal cable, and then a field terminated plug that is attached directly to the horizontal cable and then inserted directly into the device. So considering these two methods, you can see they're quite a bit different. And when we look at a comparison of these methods, with the patch cord method, the traditional method being on the left, and the new direct connect method using the field term plugs being on the right, both methods have merits to them and benefits. And honestly, from a user standpoint, I'm sure you'll have customers and preferences for using both of these methods in different scenarios. The patch cord method, it's a familiar method, and the key things that it provides are modularity and physical flexibility in terms of routing to a device with the flexibility of a patch cord, which can be quite small. By contrast, the direct connect method the big advantages there are the cost savings, faster installation, and increased reliability that it provides. And I won't read through all the bullets. You can see, though, how they compare. And one of the big things is that, and this is the news relative to standards, of course, the patch cord method is what's included in the existing TIA 568 Rev-C standard. But I'm excited to announce that the direct connect method is actually just recently, within the past week and a half, been ratified in the Rev-D, the forthcoming Rev-D version of the TIA 568 spec, which should issue or publish within the month. So now both of these methods are standard supported methods for attaching devices into the network. And what we'll do from here is now take a closer look at what would determine which method you would use. A rule of thumb that we like to use is that the patch cord method is great for tight spaces and flexibility. If, for example, the device may have a chance of moving in the future. On the flip side, the direct connect method really is the best for lowest cost and fastest installation. And again, we'll take a look at one cost savings example at the end. So given these two methods, when you think about what's the best method to use, of course, there's a number of factors, and every situation is different. But in general, there are three determining factors that are always present to help determine the method to use, the cabling method. The first is the device RJ45 port and the cabling layout. As you can see in the picture with the access point shown, what we're talking about there is the physical constraints of where the RJ45 port is located on the device, how much extra space is around that port for making room for the plug itself, and then what is the cable routing that's defined by the device. And as you can see in this device, this access point, there's a kind of a high wall on the right behind the filter and plug, which means that the cable has to be routed away from that. This is just a simple example. Cameras, for example, security cameras, have a number of different configurations which are seen, and they can be quite restricted in this area, and they may determine like a tortuous cable routing path or so forth. So this is the first item to look at, is the port orientation, location, ease of access, and then the cabling layout that's dictated by the device itself. The second factor that's key in determining is the device mounting environment. And by this, we mean everything from whether it's indoor or outdoor, to whether it's located on a drop ceiling, located above a drop ceiling, located on a wall. So all these factors come in to basically determine what sort of cabling environment that you have to reach the device, as well as if it's like the example shown with the rooftop mounted cameras. That's obviously not an application environment that is going to be so easy to get to, as easy as, say, walking up to your desk and unplugging a patch cord. So in this case, the device mounting environment might even influence the desire for the reliability of the system, which is where the direct connect method has an advantage, just because it's fewer points of failure in the link to the device. So finally, the always common factor, the third factor, is the cabling and the connector solutions that are being used by you, the contractors, or the end customers. And that's relevant because obviously there are many products in the market, and they differ in terms of their feature sets and the different options that they have for fitting into different devices. So looking at all three of these, and we've got a document which goes into this further that we've included a link for in this presentation, that goes into each of these in more detail to spell out where the patch cord method may be more appropriate, or where the direct connect method may be more appropriate, and always as a cost and time saver. So with that as a background, let's take a closer look at the Panduit TX6A field term plug. So as you can see in the picture, this is a field installable 6A plug for network devices. It's a 6A rated plug that is also backwards compatible to a 6 and 5E to 6 and 5E systems. The key advantages of this product, the qualities of it, it's easy, fast, and versatile to install. That's because, first of all, it's a simple two-piece assembly, as we'll see in the next slide. We have multiple cable exit options. So as you can see in the picture, the one plug on the bottom is a straight exit. The one above it is in an angled up configuration that can also be wired differently and flipped around to be an angled down configuration. The product is capable of terminating a wide range of cable gauges, and it's reterminable up to 20 times in the field, which means that as we get to the next slide here, you'll see that if it became necessary to rework a plug in the field, you could easily do that with the Panduit product up to 20 times. So then at the end, we'll take a look at the time and install cost savings. So what is it about the Panduit's approach to the field term plug that really separates it and we think makes the easiest to terminate product in the market? Well, it really builds on a termination technology that Panduit has had for more than a decade now in our modular jacks, and that is what we call the TG style termination. So as we build out this slide, you can see with the plug itself, we've got the front plug housing, which is the black portion in this view, and then the blue wire cap, which is the wire manager, holds the wires, and the stripped cable here would be dressed into the wire cap and then simply inserted together to terminate like a Minicom jack, for those of you who are familiar with Panduit's Minicom TG style jacks. So the beauty, again, of this system is in the field, you have very few parts to work with, and the wire cap has dressing features that allow the twist to go as close as possible to the termination and be maintained by the wire cap, and then have the wires be totally separated and put in their own designated channels to really prevent any possibility of miswiring. So let's look now at what the advantages are of multiple cable routing options and why we've introduced both an angled and a straight model of our field term plug. In the top view, you can see a straight model plug that this is the case where maybe the device and the port, the device and cable routing layout is very open and unconstrained. In this case, you can see that with this access point, that wall is cut down lower, and it enables a easy fit of a plug and the routing of the horizontal cable, because remember, this is horizontal cable which is being connected to this plug, so it's typically your standard 23 gauge solid cable. It doesn't have the flexibility, and just by virtue of its diameter, it has a larger bend radius, minimum bend radius, than say a 28 gauge patch cord. So in the top view, this is an ideal application for a straight model. But many times, as we can see in the bottom picture, there's a need for either because of the device port location, the orientation of that port within the device, and or the cable routing path that's dictated by the device itself, it can have some constraint which requires the cable to route in at an angle into the connector and or the device. And that's where you use an angled product. And we see, again, quite a bit of variation in the market with devices like cameras, for example. Now, up to this point, we've looked at the unshielded UTP version of the field term plug. This is just to let everyone in the meeting today know that we are going to be introducing a shielded version of the field term plug. It's going to have the same simple two-piece assembly as what we just looked at. It'll involve the same termination process as the UTP, which is that TG style of termination with that nice wire cap that dresses and retains the wire mapping for us. It will use the same simple termination tools, which is just a little plastic handheld tool that can be put in your pocket and just helps to push the two parts together. This will be launching later this year, and we do expect after launching with the straight version that you see pictured, to be offering an angled version of the shielded product as well. Now, obviously, this is a very active area of the market. There's a lot of options that are coming on from other suppliers with field terminated plug solutions. From Panduit's standpoint, we feel that our product actually still remains the easiest to terminate and fastest in the field, as well as fitting in more applications by virtue of the cable exit options that you have, and it's straight or angled, having dedicated optimized UTP and shielded models so that you're not trying to make one version, such as a shielded version, do the double duty to do UTP when at that point you'd be maybe overpaying and paying for features that you didn't need for the UTP versus a shielded configuration. The speed and the ease of termination is really what sets this product apart. Those two easy to handle pieces that you're going to welcome if you're on the top of a ladder and you're at ceiling level handling this, you're going to want the minimum number of pieces and the fastest, easiest way to dress the cable, which is what the that TG wire cap provides. Again, this termination technology has been used by Panduit for over a decade with literally hundreds of millions of jacks in the field. And again, the fact that both devices, either the UTP version or the shielded, will be returnable up to 20 times, so that if it has to be readjusted in the field for any reason, it's not an issue. You don't have to throw any parts away. You don't have to have extra parts on hand just to re-terminate. Now, another typical question that we get sometimes is people saying, well, this sounds great. This field term plug is really cool, but gosh, why don't I just use a modular plug? And by modular plug, I mean the picture on the lower right, which is the same type of plug that you see on the end of a patch cord. Of course, Panduit makes patch cords as well, and we use plugs like this every day in our patch cord assembly. The difference, though, is that the field term plug is really designed and it's optimized for easy field installation. The way that shows up, as you can see in the comparison pictures, is far fewer pieces with the field term plug, only two, and more obviously polarized and indexed versus the multi-part construction that you have with a modular plug. In this case, can have as many as 5 components that are much smaller, and there's a lot more intricate wire dressing required to terminate like that. So yes, it is possible to use a modular plug to terminate in the field. It is not nearly as easy to do on the top of a ladder in the typical field installation environment. So again, the field term plug is optimized for that installation in the field where you want speed and you want ease of handling. So we've mentioned the cost savings potential. Let's take a closer look now at one example. Let's say that we've got a job this would be, say, a major multi-floor enterprise building, and we've got almost 1,000 drops that are going to be run to either access points, lights, door controls, sensors, etc. These are just representative numbers that are realistic. Of course, every situation is different. Labor rates vary across the country, for example, but let's just say we're going to use $95 an hour as the labor rate that the contractor is paying out. So if we take a look at the patch cord method as a comparison, per drop, we would have material costs that would be somewhere in the neighborhood of, in this example, we're saying $21.55. And that's because we've got again, this is a 6A example. So we've got a 6A jack, we've got a housing for that jack, and then we've got a plenum rated patch cord that would be going from the secured jack to the device. Now, on the labor side, at that $95 an hour, we're estimating at 12 minutes, and that's to terminate the jack, to integrate the jack into the housing, to mount the housing, and then to install the patch cord, one end into the jack and one end to the device. Again, all these numbers can vary in any case. They're all different, but these are, we feel, fairly realistic. So that 12 minutes of time is worth $19 a cost. So when you look at the total cost per drop were over $40, and our total material and labor cost for doing these 967 drops is just shy of $40,000. Now, if we compare that to the direct connect method per drop, same assumptions, 967 drops, $95 an hour. The material cost is significantly less because other than the bulk cable, which is not in either calculation, the material cost is only for the field term plug. And this pricing level would be typical maybe that a contractor would see for the product. The labor cost now is quite a bit less. It's only 5 minutes of labor cost because the only termination that we're doing in the field is the termination of the field term plug. We're not terminating the jack and then having to mount the jack and then having to handle the patch cord and so forth. So now we've got only 5 minutes of labor at just shy of $8. The total cost per drop is less than half. And when you look at the net effect, comparing the total cost for installation of the patch cord method versus the direct connect method per drop, it's a savings of over half the total amount. In this case, over $20,000 or about $23 per drop that is being saved by using the field term plug. Again, these examples, they're representative. We feel they're realistic. We can help with estimating that, working with our sales team and with customers for specific examples. But you can see the potential, and that's really driven just by the fact that you're procuring much less material and you have much less material to install, so your time goes down. So concluding here so that we have a few minutes for Q&A, what are some takeaways? First takeaway is that this direct connect method as an exciting new approved option, standards approved option for connecting network devices. The second takeaway is that there are connectors like the Panduit TX6A field term plug that make it easy to do direct connect cabling and get all those advantages in time savings, increased reliability, and so forth. And finally, there are significant cost savings that are possible by using the direct connect method for attaching network devices. So that concludes the presentation portion of the webinar. We do have some links here that are active in the slide deck, and this deck will be made available to you following this presentation. For more detail, as I mentioned, we have a document here that is hyperlinked in this slot right here, the installation guideline. And just to give you a quick peek of what that looks like, it goes into more detail here, as we can see, in looking at these factors of which cabling method to use, details of devices, and comparing, contrasting where you might be obligated to use a patch cord, for example, because of fit issues versus the flexibility of a device where you can use the direct connect method. So that is linked here in the document that you'll receive. And if you have any questions, you're always welcome to email me, tmba@panduit.com.